South Korea, home to more than 40 million people. It's an East Asian economic giant, a vital commercial hub in the region. One of the greatest obstacles to South Korea's upward climb is its geography. Some of the world's most impassable terrain exists here. No one has ever tried to cut a route through its 69,000-kilometer rocky landscape until now. $15 billion worth of rail tracks, tunnels, and bridges are to set a course through its mountains from Seoul to Busan, paving the way for one of the fastest trains in the world, the KTX. Nothing like it has ever been attempted before. It's an engineering marvel that will not only change the face, but also the fate of South Korea forever. The Korean Peninsula, a rugged finger of land that lies on the East Asian Sea. Nestled within this labyrinth of rocks is Seoul, the South Korean capital. Home to over 10 million people and the heaviest concentration of industries in the country. A host of transport systems help connect the busy metropolis to its neighbors. But this million-strong army of vehicles is beginning to clog vital arteries. Almost every day, things grind to a halt on the 412-kilometer link between Seoul and Busan, Korea's second-largest city at the other end of the country. 73% of South Korea's population is concentrated along this corridor, creating a nasty bottleneck along a lucrative highway. Busan is the third-largest container port in the world. The thriving harbor city is a hub for trade and tourism, and home to over 3 million people. The problem is, it takes over 4 hours to get from Seoul to Busan. The government had to find a solution.
The link between Seoul and Busan in Korea is unique. More than 70% of our population and industry is concentrated here. So issues like transportation and logistics between Seoul and Busan are very serious.
The task falls on the shoulders of Chung Jong-hwan, CEO of South Korea's rail network.
We reviewed many alternatives while thinking how to solve this issue. And we came to the conclusion that it would be best to build a high-speed railway.
The effectiveness of high-speed rail has already been proved by the TGV line in France. The network revolutionized public transport, making once remote regions of the country just a train ride away. Japan witnessed a similar revolution with the Shinkansen, also known as the bullet train. In South Korea, engineers put their heads together to design a new high-speed train, reconfiguring the French TGV model to suit their unique requirements. The biggest difference between the Korean prototype and its predecessor is its size. Weighing in at 770 tons, it's almost twice as big and heavy as the TGV. Its 935 seating capacity also means it can carry 3 times more passengers. The Korean train's radical dimensions will pose some practical challenges. But that's not the only problem. 290 square kilometers of South Korea is occupied by water, so bridges have to be built. But with over 100 bridges needed for the new railway, engineers must abandon conventional bridge building techniques that take months to construct just a single bridge. A faster method will need to be devised. Then comes the bigger test, to lay 412 kilometers of tracks from Seoul to Busan. Korean engineers will have to construct 51 tunnels through 190 kilometers of undulating mountainside. It's a daunting task. The project will require manpower and machinery on a scale never seen before in South Korea. In spite of the odds, the project is given the green light, paving the way for a new heavyweight in the world of high-speed trains. With over 10 million cars on the road, South Korea's traffic congestion is a huge concern. But hope now lies in the country's revolutionary high-speed rail project. Of course, an engineering task of this magnitude requires a giant workforce. 7,000 workers per day, amounting to 2 million people a year, are needed to make high-speed transport a reality. Despite the scale and cost, the ambitious plans get the go-ahead. The ultimate goal? To connect Seoul to the port city Busan, some 412 kilometers away. Very quickly, the engineers identify their first challenge: to tackle the rivers and valleys that stand in the train's way. In order for a high-speed train to reach maximum speeds, it needs to run in a straight line. But running straight in South Korea's mountainous landscape means going through them. 32% of the entire rail network will require tunnels. Rail engineers have to dig a route through its mountains to the port city Busan. But that's easier said than done. Korea's peaks are made from the toughest rocks on Earth, granite. To dig tunnels through barriers this strong in a conventional way would be near impossible. So engineers take a more direct approach. They blast their way through it. To complete one tunnel, they will have to use the combined power of blasting and drilling in order to defeat the granite. The success of this entire operation is the responsibility of one man. Project manager Yoon is the drill master of this march into the mountains.
More than 70% in Korea is mountain. So in order to build such a very directional high-speed rail system, you cannot but face it. There's so many tunnels.
To do this, Mr. Yoon has several weapons at his disposal. Meet Jumbo, a $1.5 million mammoth drill. Jumbo needs to drill more than 130 40-centimeter holes. As each hole has to be filled with explosives, it's vital they are drilled precisely in the right position to create the perfect blast. The explosions are also coordinated precisely so that an even layer of rock is removed across the entire blast surface. Now, Jumbo's tag team partner, the charging car, takes over. It's bringing a different kind of ammunition to the game plan. After each controlled explosion, the blast face has to be flattened before drilling can begin again.
If we didn't shoot the shockwave right now, then the rock surface can be moved. This very dangerous condition can be made.
The newly exposed rock is now weakened after the blast. It literally has to be glued into place with a blast of liquid concrete. And here's where the charging car comes in. This process is called shotcreting. As the name implies, concrete is shot out at extremely high pressures, filling up cracks and securing the loose bedrock. This synchronized operation takes place on both sides of the tunnel. Besides crushing granite barriers, rail engineers also have to make sure that opposing tunnels will meet in the middle. Because teams can't actually see where they're going, they need a little help from a higher power to ensure they're heading in the right direction.
Even 1 millimeter difference can make different tunnels.
To make sure the tunnels join up, GPS, or the Global Positioning System, helps map out the exact route to a centimeter via satellites 20,000 kilometers above the Earth and conveyed to receivers on either end of the tunnel. The eyes in the sky turn complex tunneling work into a simple equation. Despite all the care and precision, things don't always go according to plan. The engineers make a startling discovery.
터널 중심으로 주위에 여러 가지
Different ores were mined at a river surrounding the tunnel, so the problem of the tunnel stability was raised. We thought we could solve the problem technically, but the high-speed rail is being designed to be safe for 100 to 200 years.
While their high-tech machines sit dormant in the tunnel, the team has to deliberate on whether to push on with the tunnel. In theory, the tunnel can be completed, but there's no way of knowing how weakened the mountain has become because of the mining activity. It's a dangerous gamble. Structural weakness in either the tunnel or the mountain could mean life or death for train commuters. With safety a #1 priority, the team makes the difficult decision. The tunnel has to be shut down. A new one has to be built, and the nearest suitable location is 6 kilometers away from the original site. A minor detour for the train, but a major setback for the team. So it's back to work on a new tunnel, just one of over 50 that must be built during the course of this project. The tunnelers have another challenge. The KTX train is heavier than the Eiffel Tower and longer than 4 football fields. Tunnel sizes on the line have to be enlarged to a generous 107 square meters to accommodate the train. The new tunnels dwarf Germany's 82 square meter and France's 62 square meter designs. But enlarging the tunnels also sets up the next challenge. When you've got 700 tons of metal hurtling at 300 kilometers per hour through an enclosed space like a tunnel, things can get noisy.
When the train comes and approaches the entrance of the portal, then the airs can be compacted through the tunnels.
With so much pressure building up, there's only one way the air can escape, and it does so just like a bullet leaving the barrel of a gun.
And just after the tunnels, there are big noise, bang!
The resulting sonic boom can be heard and felt for miles around.
Air transferred vibration, all the windows and any other things, every time shake. There's a big problem and very complaint from the neighbors. Big problem.
To solve this potential problem, the Koreans decide to design their tunnel mouths in the shape of a bell.
The edge part is like this. This is the edge of the bell. This is for special design because of the reduction of the air pressure.
As the train exits, the bell mouth disperses air upwards and outwards away from the train, therefore reducing high pressures built up within the tunnel. The design helps reduce noise and vibration by more than 30%. The tunnels aren't the only construction feats being undertaken by the railway's engineers. "290 square kilometers of South Korea is occupied by water, so over 100 bridges have to be built. But how do you build over 100 bridges in just 6 years? Engineers have to speed up the bridge building process if they're to meet the deadline. They need to find a technique that is both fast and efficient. The team turns to an ingenious method of bridge assembly called the precast span method, or PSM. The PSM method cuts bridge building time from a month to just 3 days. This is achieved by changing the way the bridges are put together. While conventional bridges are built entirely on location, PSM bridges are fabricated in sections at temporary factories erected close to the site itself. With several sections being built at once, this significantly reduces construction time. To transport the bridge sections out of the factory, a monster machine is brought in to add some muscle. This is the saddle carrier, all power and steel. It inches forward at only 5 kilometers an hour, but is capable of carrying up to 750 tons on its back. Lifting 600-ton bridge sections is a piece of cake for the giant pack horse. Each cubic meter of these bridges is capable of supporting 15 tons, creating a total tensile strength of 7,600 tons, the combined weight of 1,000 full-grown elephants. More than enough to cope with the crunching speed and weight of a 700-ton train. With tunnel and bridge construction well underway, the high-speed railway slowly starts to take shape across South Korea's landscape. Meanwhile, over in France, Korean engineers are busy making final adjustments to the star of the show, the KTX train. Today, 12 KTX models arrive in South Korea from France. If all goes to plan, Korean engineers hope to build another 36 trains on home ground. The KTX is designed to be a vastly superior model when compared to the French TGV high-speed train. It now dwarfs its Gaelic predecessor by a staggering 300-odd tons, with almost twice the passenger capacity. This mega train can hold 935 passengers, the same capacity as 2 Boeing 747s. But despite its big proportions, the KTX still needs to reach speeds of over 300 kilometers an hour. The only solution is to further streamline the nose of the train, an essential process in reducing air resistance across its surface. The engineers look to an unlikely source for inspiration. When it comes to high speeds, nothing in the water can beat a shark. The shark's head does most of the aerodynamic work, forming an area of low pressure that the rest of its body slips into. This pocket of low pressure allows the shark to slide through the water with little effort. Engineers apply similar principles to the KTX. In the wind tunnel, the same shark-like effect can be seen around the lead car. But it's not just appearances that designers need to look out for. The size of the KTX can also lead to increased levels of noise and vibration when the train runs at high speeds. New modifications are needed. The wheelbase that connects the coaches together has to be completely redesigned. Conventional wheelbases, though, known as bogies, tend to become unstable and noisy when trains hit high speeds. To rectify the problem, engineers discard the standard bogie system. They create a more stable connection, effectively cutting down noise and vibration. The new bogie works just like a skeletal joint, articulating and supporting adjoining bones. The KTX, now bigger, stronger, and quieter, is ready to face its next challenge. By increasing its passenger capacity, the KTX train designers have to change its size and shape. To prove it still has what it takes to be a high-speed mover, the train must hit 300 kilometers an hour. To achieve this, engineers inject more power into the KTX by fitting a massive 18,000 horsepower engine, enough muscle to steer an aircraft carrier. Then, to make sure this speedy behemoth never runs out of energy, 25,000 volts pass into the train via a continuous feed along the entire length of the railway. Now, all that needs to be done is to put it through its paces. It's a freezing winter morning on the day of the train's trial run. Not ideal conditions, but surely a good test of its ability to survive South Korea's coldest winters. Although the journey starts smoothly, things start to change as the train approaches its top speed. One of the rear coaches starts to swing violently from side to side, halting the test run immediately.
The French and Korean people were very shocked. They didn't know how to interpret this phenomenon. They were very surprised, as this was the first time it happened in the world.
A thorough investigation is launched, and before long, the source of the problem is unearthed. South Korea's freezing temperatures caused ice to form in the rails, and with the track so slippery, the KTX cannot get a proper grip. This makes train carriages swing dangerously as it reaches maximum speed. In the workshop, engineers undertake a full examination of the train's undercarriage, searching for any visible faults or weaknesses. It soon becomes clear that the problem lies in the wheels of the passenger coaches. While older TGV trains carry 14 coaches, the KTX has 20. A longer train means more instability, especially on icy tracks. No other high-speed train has had to deal with these additional problems. So the original wheel blueprints have to be reassessed. It's up to Chief Researcher Dr. Lee Chan-woo to come up with a suitable remedy.
There are now two types of wheels. First of all, the gradient of the wheel section is 1 out of 40 on the lead car, just like the TGV. In the case of our passenger cars, however, the gradient of the wheel section is 1 out of 20. This type of wheel is only used in Korea.
The coach wheels now have a narrower edge, cutting down the effects of the ice and preventing dangerous shaking, no matter how bad the weather gets. It should be happy days for the KTX designers. But 8,000 kilometers away, a tragedy occurs to put the integrity of the project under the spotlight. (1998). a small town in Germany called Eschede. A German-made ICE high-speed train has collided into an overhead bridge. The train is a total wreck, and the crash has claimed the lives of over 100 passengers. The disaster is about to go down in history as the world's first and worst high-speed train accident. A post-mortem of the accident reveals a frightening chain of events. Moments before the crash, the ICE train speeds along at 200 kilometers an hour. Suddenly, a wheel comes apart, and its outer rim punctures through the floor of a car at the center of the train. In a matter of seconds, the embedded rim slams against the railway, lifting the carriage off the tracks. The front of the train is left intact, but the rear cars are derailed and sent crashing into a 300-ton bridge. Back in Korea, the German accident raised questions among its 7.3 million train passengers about the safety of their own high-speed train.
Our KTX did not have the double wheels like Germany's ICE, but single wheels.
Fortunately, Korea's unique wheel design would help prevent a similar accident. The German design incorporates both inner and outer wheels. In the train crash, it was the weakened seal between these two parts that gave way.
If even a fine crack appears in this area, it can be dangerous when the wheel is running at high speeds.
The KTX designers had already created a completely solid wheel for their train, so there's no risk of collapse. However, Korean engineers were still not satisfied.
We learned how important safety is through this accident, and we were thinking once again about the safety of our own high-speed railway. It became an important motivation for us to put things into order.
With safety the order of the day, the South Koreans created a number of unique devices to be incorporated into the body of the KTX. The first of these is a shock absorption device in the head of the train. The device, perforated with holes like a honeycomb, works to absorb the full force of an impact without disabling the rest of the train. It's capable of absorbing a head-on collision with an object weighing as much as 700 kilograms, even while the train is running at top speed. The designers then set about adding a preventative measure, improving the train's brakes to make it come to a stop even faster than before.
Safety is the most important part of our system, so we paid attention to our brakes and incorporated an additional braking system.
Besides conventional disc brakes that exert direct pressure on the wheels, the KTX employs a regenerative system that redirects energy into reversing the train. With this combined force, the KTX needs just 400 meters to go from 300 kilometers an hour to a complete standstill. But the German crash wasn't down to just mechanical error. A lapse in the driver's concentration was another contributing factor. To address any unforeseen human error on the KTX, the South Koreans developed a computerized monitoring system to keep a watchful eye on the driver. He is continuously monitored throughout the journey. If the computer detects a lack of activity at the controls, an alarm sounds. If there's still no response, the train is then taken over by an operator at the KTX control center and automatically brought to a stop. With these devices in place, a safe ride is guaranteed on the KTX. But when the rail building operation moves from the countryside to the urban landscape, engineers face a formidable, though familiar, obstacle. Welcome to the Gyeongbu Highway, Seoul's answer to traffic hell. Its economic importance is so great that it can't be stopped, and it can't be diverted.
We can't stop the expressway. It would be just like stopping an artery of our country.
The problem is that the highway lies right in the railway's path. They can't stop the traffic. Engineers have no other choice. They must build a bridge over the highway. And to do that, they have to do something that has never been tried or tested before. South Korea's railway engineers, having overcome all that nature has thrown at them, now face a river of metal and concrete that refuses to budge. Busy Gyeongbu Highway is an important link between Seoul and the port of Busan. But engineers have to find a way for their train to cross it.
The problem was, in order to carry out the work, we could not interrupt the expressway. We built an arch bridge next to the expressway and moved it into place by the rotation method, which did not interrupt the expressway.
Engineers assemble the arch bridge alongside the highway. The bridge is constructed first, and then the supporting framework is built at either end in preparation for the actual rotation. A temporary support pillar is anchored at one end, with a rotating device at its pivot. In theory, the rotating mechanism will be able to turn the framework slowly around to reach its supporting pillar on the other side of the highway, forming the completed bridge. It's a team effort. Workers play their part precisely, as this particular construction is a first for everyone. The process may sound straightforward, but there's a host of unknowns that make this procedure one of the riskiest maneuvers in the KTX project so far. They hammer away day and night to complete the job. Now all the team needs is a little help from the heavens.
We checked the weather reports and chose a turning date when rain was not forecast.
The day finally arrives for the arch bridge engineers. The bridge is built, and all supporting structures for turning it are in place. The team knows they only have one shot at this. Nothing must go wrong. The bridge rotation begins, moving at a snail-like 7 centimeters every minute. From start to finish, the precarious journey of the arch bridge over the highway takes 13 hours. Bridge engineers can hardly wait to see their theory become a reality. At the end of a long day, the arch bridge finally moves into position.
We are proud that it was carried out without any interruption to work on the highway, and I can say it was one of the first times this construction method was applied in the world.
But while bridge engineers celebrate another victory, a nationwide catastrophe strikes suddenly and threatens to derail the project for good. In 1997, South Korea is hit by a financial crisis that is sweeping the region. The timing couldn't be worse. Having conquered over 20 mountains and river systems and completed over 60% of the railway, the KTX is on the homeward stretch. But now, all progress has come to a grinding halt. Hailed as the driving force of South Korea's future, the question now is whether the KTX high-speed rail project is worth saving.
The transportation problem in a corridor between Seoul and Busan is very serious. So if we don't solve this problem, it's obvious that a lot of other problems will occur in Korea in the future. Even though there were some difficulties, we concluded that this project had to be carried on without fail.
But that's easier said than done. With 60% of the project already completed, the team has to convince investors that the KTX line must be finished. The budget also has to be re-evaluated. It takes 2 years for them to find a solution. With the help of the International Monetary Fund, South Korea rejuvenates its economy, and by implementing budget cutbacks, the high-speed rail project is restarted. Finally, after months of uncertainty, the KTX teams return to work. But in these lean times, things will have to change in order to complete the line. The tighter budget's biggest victim is the track on the railway line itself. A standard feature on all high-speed rail systems are continuous welded rails, or CWR. Unlike conventional railways, CWR tracks are free of joints, so there are no jolts or vibrations while trains travel at high speeds. In order to safely maintain speeds of 300 kilometers an hour, CWR is a crucial element of the project. But the price for laying over 400 kilometers of continuous tracks from Seoul to the port of Busan is simply too steep for the reduced budget. A temporary solution is needed to meet the deadline until more money comes in. Engineers decide that their best option is to stop the continuous tracks at the city of Daegu and then connect it to an existing conventional line from Daegu to Busan. It's a bold strategy, and one that has never been attempted before. They're taking a risk with this new plan, but they've got to get it right the first time. The compromise means an extensive upgrade to the conventional line to accommodate the KTX train. It also means that the trains now have to slow down to around 250 kilometers an hour. But there's another problem. Continuous rail tracks are thinner than standard tracks. So by going back and forth over an uneven railway line, trains can cause dangerous wear and tear on their wheels. It's up to Chief Researcher Dr. Lee Chan-woo to ensure that this compromise works. Train wheels are tapered, with one side much wider than the other. So if the flange becomes badly worn, the wheel is no longer secured on the track and starts to slip or skid.
At the point of connection between continuous welded rail and conventional rail, there will be a deformation in these areas of the wheel flange. They are in constant contact with the rail, and there will be intense wear and tear taking place. If the train runs like this, it will be dangerous.
A stronger wheel has to be produced to deal with the exertions of crossing from one type of track to another. In order to keep the wheels running at maximum performance, the engineers monitor them continuously and replace them at the slightest sign of wear and tear. At the KTX workshop, a supervisor and his team put one particular train through a rigorous examination.
KTX 18호에 치부되어 있던 차인데 저기 차축인데
This is the axle from KTX train number 18. There was a problem with its wheel. Over there you can see the new ones. The wheel is worn, so we have to replace it. Originally, its thickness was 920 millimeters. Now it's 850 millimeters.
That's an amazing 7 centimeters. With this intense friction wearing away wheels made of solid steel, it's essential that the entire fleet of KTX trains are inspected on a weekly basis. Now that these new refinements are in place, the wheels will last much longer than their previous design. With the new train wheels ready to rock and roll, South Korea gets ready to welcome its newest railway line. After 12 painstaking years, and the combined effort of a workforce 11 million strong, the main KTX railway line from Seoul to Busan is finally open. The high-speed line is now uniting the country in a way no one thought possible. For the first time in its history, any location in South Korea can be reached from Seoul within just half a day. The KTX network is also capable of transporting 6 times more people on the Seoul to Busan line than the French TGV service does on its Paris to Lyon route.
In the olden days, we had sufficient time to sleep, even when we traveled from Seoul to Daejeon. But now I realize that by traveling at such high speeds, you are unable to sleep, because you may miss your stop at Daejeon and end up going all the way to Busan.
With the KTX breaking the 300 kilometers an hour barrier, South Korea has become one of only 5 countries in the world to develop high-speed railway technology. With a fast and unobstructed corridor between the capital and its port city at the other end of the country, South Korea is experiencing the economic benefits.
After KTX was opened to traffic and the speed became faster, it became feasible to go to Busan from Seoul, finish business in the morning and come back to Seoul on the same day.
Thanks to the KTX, travel from Seoul to Busan has been cut from 4 hours to just 2.5. And the summer capital of Korea is experiencing a surge in visitor numbers. KTX trains now run 24 hours, 7 days a week, arriving on time at every station at an unprecedented 98% punctuality rate. For the man who kicked off the project, it's a tremendous victory and all part of a bigger dream for Korea's railway.
Historically, the Silk Road connected China to Europe. But this Iron Silk Road of the 21st century will connect the Asia Pacific to the continent of Eurasia and further into Europe.
But with the KTX traveling smoothly through its tunnels and over its bridges, it's a much more personal victory for people like project manager Yoon.
You cannot imagine the feelings, inspire the feelings. Oh, I did it.
But with typical Korean industriousness, railway engineers are already building a faster KTX train. This next-generation high-speed train, with its revolutionary aluminium body, is 20% lighter than its predecessor and almost 30% faster. It's set to drive the KTX project into the future.
Our train can run from 350 to 360 kilometers per hour. The actual design speed is 380 kilometers per hour.
With the KTX already evolving, South Koreans will soon get a glimpse of the future of train travel. Arguably the most complex high-speed rail system in the world, the KTX went up against Korea's geographic obstacle course and won. A true man-made marvel.